Now for this question, yep, we have a graph of the voltage, AC voltage, and they ask me what's the time interval between Q and R, between here and here. Okay. So if I read the question, a rotor is rotating, well, a rotor connecting, well, is rotating 10 at 10 hertz, 10 revolutions per second. So the period must be 1 on 10 seconds. Okay. So if you look at this section of the graph, it is half of the period. Okay. The whole period is this. The whole period is this, but this part between Q and R is only half. So the time is going to be yep, times half, which is 1 on 20 or 0.05 seconds. So question three, yep, seems very complicated, but okay, in this case, I just look at the final answer, final question. They ask me the peak-to-peak voltage of 1100 volts RMS supply. Okay. So if the RMS voltage is 1100, okay, I need to find the peak-to-peak voltage. Okay. So let's find the peak voltage first, okay, which is the RMS times square root of 2. Type it in your calculator, you have 15556 volt. Okay. However, when we have to do peak to peak voltage, okay, this is the peak voltage from, yep, peak to peak voltage should times this number by 2. Okay. So it's basically the peak voltage times by 2, 3.1 times 10 power of, well, let me write it fully, 31126. To make it simpler, 3.1 times 10 power of 1, 2, 3, 4, 5 volts down. Question 9. Yep. For this question, we have alternator. This is the output in the AC. Yep. So what is the frequency? So if you look at, and be careful with the unit, it's in milliseconds. Okay. So when they ask me to find the frequency, I need to find the period first. If I trace one period of this graph, the period is going to be that's 2, 3, 4. Sorry, 2, 3, 4, 200, 400, 20, 40, 60. Sorry, 80 milliseconds. Okay. Converted into second, it will be 0.08 seconds. So the frequency is 1 on the period. Okay. So 1 divided by 0.08. It's going to be 12.5 Hertz. So every second there are 12.5 period, okay? 12.5 rotation. So down. Question 10. have 36, just read the question, we have 36 globe, so connected in parallel. Yep, well, connected in 3 strings, so each string is parallel to each other, so each string is 12 globes. Now, yep, the voltage supply is this, so and the power of all is 48. So what's the power of each globe? Yeah, for this question, I mean, it's well, it's simple. I mean, but how do I explain it? Okay. So if I draw a circuit, I have all the globe. So I have all the globe here. This is one string. If I draw the next string, I have other string here, I have other string here. So using what we learned in electronics, this is a parallel circuit. So what's happening is current come here and well, let me write it down. So if I have current come here and it splits up I1, I2, and I3. Okay, and since the resistance in I1, I2, and I3 are the same, so the total current has been divided by 3. So the current I1 equals to I2 equals to I3, because the resistance of those 3 strings are the same. So if the resistance are the same, and in parallel circuit the voltage is the same, so V1, V2 equals to V3, the power of each globe must be the same, P equals to Vi. Okay. And in total there are 48 volts, and there are 36 globe, so 48 divided by 36, I have 1.33, so 1.3 volts each for each globe.